we had a request for predicting the product of reactions that we've learned the mechanisms to. So in both of these, there's hydration, and yours will be one of the little boxes will be for hydration. In this case, it's the big box, and the other will be for hydrohalogenation. I might switch the order. That won't mess you up, right? Okay. And you do remember in hydration, you get an OH on one carbon and an H on the other. You remember that? And in hydrohalogenation, you get an H on one carbon and a halogen on the other. So two of the minor products, and you just go straight to minor, because the major products are going to be rearranged. I promise. Look, both of these are candidates for rearrangements, and I will tell you how I know. This thing can rearrange in two directions. If there's a cation here, name what element can rearrange. Rearrangements are either called hydrogen shift or carbon shift. A hydrogen will shift from an adjacent position, which is here, to make a cation there tertiary. That'll be a major product. Another major product will be if what shifts, and if there's a cation here, you're allowed to rearrange from the adjacent over here. What's going to shift this time? Carbon, and specifically a methyl, right? Good. That'll be your other major. But don't do the majors first. Do the minors. They're direct. You put a BR on the left for one minor and a BR on the right for the other minor, and those are the nice easy points. We like easy points. We'll do those first. Copy the skeleton, no rearrangements. That's in the major box. Thanks for seeing that. Yeah. Can I get my molecule? Can I get it out of there? Why are you being so mean to me? Sorry. Since I was there. Okay. Okay. And you put this BR on the left on one of them. And you're done with that. And on the right with the other one. So the minors are easy, right? And you do know there's an H on the other side of each. There's an H here and an H here. But you don't have to show those. For me, I need to look at the two cations before I think about the other products. So I know it's not a mechanism question, so it's not mandatory to draw the cations, but if you're seeing them, then you can see the rearrangement. So I'll put them off a little bit up here off the top of the screen. Cation number 1. Oh, cation number 1. I did it again, didn't I? You get rid of the pi bond to make the cation. You got that one. And you got this one. And I'm going to move this H. And I'm not going to show what I get. I'm just going to draw the product. H goes there. Thank you. Everybody's on my list now. And the cation went down here. Right there. There's going to be a cation there. You see it? So I didn't draw the cation. Do I have to? No. Here I'm going to move a methyl. And draw what I get. Well, there's going to be the isopropyl here. And we move the methyl up there. And we got isopropyl there. And where's the cation this time? Down there. I like that. It's that one, right? I knew what you meant. Yeah. And we put the BR down there. Wasn't that bad, was it? No. Hydration, just draw the two products that result from OH on the top of the alkene and OH on the bottom. Cyclooctane, we don't love drawing it, but we got it. OH on one carbon, H on the other. Don't have to show the H. Did it again. Can't do that.
So we don't do anything with the one on the bottom, H2SO4?
That's the catalyst. Catalysts do not show up in products. because they don't get used up in the reaction. Now do the same thing for the other carbon of the carbocation. Sorry, the other carbocation that would have been produced in roughly equal amounts initially, because they're both what category of carbon?
Minor.
Both what category of carbon? Give me a degree sign and a number. Secondary. So you can't say one was a more stable cation than the other. But I do believe that tertiary carbocations are definitely possible, or ring expanded carbocations. Yeah, those are the ones I like. Okay. So here's your two cations. Similarly to before. Going to try to be a little smarter about it this time. Was that all done in one sequence? No, apparently not.
It's easy, actually. 10 points.
I know. She's feeling it. That's good. For nothing. You're doing work. She said 10 points for nothing. She's being modest. So my cation, there's one way to rearrange that one. And there's, I think, 3 ways to rearrange this one. Once again, yeah, there's an H there, right? That's one of your possible rearrangements. Here's your other possible rearrangement, and here's your third possible rearrangement. And upstairs, what's the only possible rearrangement? This one, right? This upstairs cation is what I'm saying. Which one's the only? You're allowed to rearrange from an adjacent branched carbon. That's this one. This is not branched. It's drawn terribly. It could be branched, but it's just bad drawing. Yeah, branched. But if you move the methyl, you go from a secondary to a secondary. That's not happening. What are you moving instead of a methyl? Hydrogen. And we already had a student says this, that makes this thing easy, right? I got up there, that's going to put the OH on this position, right? So can I say this is, this could be an epic fail. Oh, I'm starting to feel it. What's that symbol again? Rearrangement A, B, C. So this is from rearrangement A, right? And what about B? Oh, man. I mean, I'm going to try to do it right here. Which bond broke? H. Cation ended up down here, correct? Right there. That's where the OH is. And that's rearrangement B. And C and D downstairs. I want to be able to see them. You can still see the methyl. It's okay. The square's still there, but all right, which bond broke in rearrangement C? This bond, right? I'm gonna get rid of it. Ooh, that's a big eraser. My strategic erasers here. And then the next one was the D. I did D. This is the same as this. No, it's not. Oh, look at that. He's so crafty. That's the last rearrangement. Yeah. That I broke the same bond twice. I just had the arrow going a different direction. Mechanisms are confusing enough without me pretending that drawing an arrow to the left is different than drawing it to the right. It's not. Okay. So I broke that one. Now I got my eraser and break this one, right? That'll be rearrangement D. And rearrangement C. And your new bond is here. Your cation is up on the octagon right above that, right? So that's where your OH goes. And this one, your new bond is there. And your OH goes here. So it doesn't even have to be drawn like a pentagon, does it? I don't mind. Much easier to see this way when you draw it the same way, isn't it? Otherwise, how did that happen? That's when I first saw it. That's what happened to me. I'm not seeing it because it looked different. And so we had the two directs. We had the hydrogen shift from the top. This is not going to be major, is it? You're saying, wait, it's tertiary. It's got to be major. I have these two ring sizes, no longer ring size 4, right? No explanation needed here, but I'm going to be circling these guys, hot pink or, yeah. They both went beyond the rings, so the angle strain and the torsional strain. And I think that's enough for this video. That was a good review video, I think.